So this is supporting the Scala ecosystem, stories from the line. It is basically going to be, actually I'll tell quick about myself, and that'll explain kind of what the talk's about. So quick about myself is I'm a problem-solving enthusiast at Lightbend, which really means I'm the developer support manager. So I always make it tell people it's akin to Stack Overflow++. The harder questions you see on Stack Overflow, that's the kind of stuff that we get. So it's a fun job, in my opinion, where you get to solve a bunch of different problems. And that's what we're going to be seeing is some of the more interesting cases. Realistically, it's going to range from kind of more complex cases to some simple ones, just so that it covers the crowd pretty well, too. I'm also a spreader of knowledge. I'm a Pluralsight author, Stack Overflow answer, and I answer the questions through Lightbend, too. So I really love to learn, or I love to teach, as well as I love to learn. So both sides of it, which is essentially why I'm here today. So the scenarios we're going to be covering are going to be a Scala ClassCast puzzler, so a bit of a puzzler. Everybody loves puzzlers. Akka cluster external communication, something we've gotten a fair amount of. So in fact, I think internally we have a frequently asked questions article for it. As well as a subtle workaround for a play security exception, no such method, which will become kind of something else. We'll see it whenever we get to it. Scala value load order and sorting a map. Those last two, realistically, I added them in there just to allow for time. They're going to be the easier items, so if we don't get to them, it won't be the end of the world. The first four are the most interesting, in my opinion. So moving on. So the first item is the ClassCast puzzler. So we had a case come in where they had a simple method just like this. So they want to create their own add method. It's generic. And the first thing you're going to see that probably makes you kind of question it is this as instance of. But you can see that their implicit is for numeric. So realistically, whatever they're casting it to should work. So sure, you're going to say, okay, of course you're going to get a ClassCast exception. You're doing an as instance of. But again, it's forcing numerics. It realistically should work. Let's find out what happens. So whenever we pass in an integer, it adds. So one thing I didn't say is, and you can see it's adding 1, basically. So the method would be better named as add 1, but either way, whenever we add 1 to 1, we get 2. Works perfectly, we're happy. Now, what happens whenever we add a 1.0? So now we get a ClassCast exception saying, ClassCast exception, where the integer cannot be cast to java.lang.double. So it's kind of like, okay, why is that happening? Let's kind of see. 1 as instance of t, it's a double, it's numeric, it should work, right? And even if you go and do that, 1 as instance of double, it works. In the REPL, it works. So why, whenever we're passing it in these generic ways, is it not working? So let's dig a little deeper. Here, you can look at kind of what this boils down to, which is going to be this num make numerics, but the key important thing here is box is runtime, box to integer. So the compiler behind the scenes is kind of no-opping this 1 into an integer. So it's forcing it and saying this 1 is an integer. And ultimately, then whenever you go to this plus method, you're passing the generic is saying, hey, this is going to be a double. So you're going to say a double with a double. Yet we just boxed it to an integer. It's going to now crash. So now that we have a little bit more idea of what's going on, we can even simplify this method. We can just say, let's get rid of just the addition part of it. We can even just go down to creating a generic one as instance of t, and the element, we're just going to throw it away. We more care about the actual type that's being passed in. So still, we end up with this box to integer, and ultimately, whenever you try to cast it to a double, then you end up with this unbox to double. Your box to double 3D, and whenever you unbox, I think I may have a typo, but I think that's supposed to be unbox to integer, but or box to integer, but either way, you end up with the same crash. So ultimately, the problem here is just type erasure. So behind the scenes, the reason we were able just to reproduce the same problem with that simple method is because behind the scenes, it's really one as instance of object. So even though you have the types and everything in there, and it looks like it should work, the compiler thinks it should work, it's because behind the scenes, compiler thinks it should work because it's saying, hey, it's an object. So I'm not gonna get into this part. I'll put the slides up, and for anybody who's really curious, I wanted to put this out there as a fun thing to add to it. This case was, I was helped with by Jason Zog. So one of the benefits of working at Lightbend is you work with some really, really intelligent people. So he kind of taught me some stuff about, hey, the Java P, you can basically inspect the Java using Java P, your class and everything, and he can boil it down to just doing these as instance of on generics, and you'll be able to see that where this blows up is finally on a check cast. So for anybody who goes ahead and runs that, like I said, I'll post it, and you'll be able to run those in the REPL, and you'll get a crazy amount of stuff, but you'll see that there's eventually a check cast, and that's where it blows up. So, next thing, the Akka cluster external communication. So, we've got our Akka cluster, it's running happily, and we want to send a message from an external point, an external actor system or something, and we want to send it into our Akka cluster. One way you can, I guess the question is, how can you do this? And one way that had been promoted for a while is to use a cluster client. So that's going to be, say, hey, I'm going to wrap this actor and say it's a cluster client, and behind here, inside of here, there's a cluster client receptionist. And this will work. However, what's going to happen is you're going to be really tightly coupled to your remoting and make sure the serialization and Akka versions and everything between your client and your source there, that they're going to be required to be pretty much the same thing. So realistically, not a good choice. So that's where clients came in and said, hey, we want to use something like stream refs or something like that. However, again, whenever you get to remoting, in theory it'll work, but you're going to be tightly coupled, as well as you run the risk of this kind of connection issues or something like that, because they're not actually forced to be in the same system. That's where Akka's clustering is going to be a little bit better. So what's better than that? So nowadays we've got Akka HTTP and Akka gRPC. I'm not going to get too much into the internals of those, because that can be a talk of in its own. However, the key here is that you're creating an interface that this message is going to go to. It can be, now you're not coupled to your client being Akka or anything like that. It can be anything that can talk to this thin interface through like HTTP or anything like that. As well as both Akka gRPC and Akka HTTP, both allow for easy streams. So whenever customers said, hey, we want to use streamref, Akka HTTP and Akka gRPC still allow you that capability. So those are the ways to go. I don't know if it's on or actually it has moved into the documentation. It's not necessarily in big bold letters, but we do say, hey, you should think about, instead of using cluster client, you should be using maybe HTTP and gRPC. Okay, the next item is play security exception. So this one actually is a support case that came in, but realistically is referencing a play framework issue that is actually still outstanding, but I believe they believe it might be fixed in the upcoming play version just because of our upgrades in Akka HTTP. But what it is it's going to say, okay, the Java util collection parallel stream raises a security exception when called inside a controller's action. So let's see what this looks like. Pretty simple method. You can reproduce this really simply. You just say, okay, I cut out like the cruft around it. This is inside of a controller. So you've got a simple get foo, get bar, just returns strings. And behind the scenes, the problem is this supply async method. Whenever you hit that supply async method, even though, I mean, it's simple code, it should work, everybody's happy. Realistically, the problem is that behind the scenes, it's using a fork join common pool, which is really, really locked down, and whenever you go to use it, you end up with that security exception. So again, it's a bug inside of play, but we need to fix it. I mean, customers are hitting this, we need to make them happy, right? So we need a workaround while the fix is coming out. I mean, the version of play that is supposedly fixes it isn't even out yet, and it's a major version release. Customers are gonna stay on old versions for a while, we know that. So how do we fix it? Luckily, supply async can have a context passed in. So you can simply, inside of your controller method, you can simply inject the default execution context, and what this is going to do is this is going to pass in the execution context that play uses. So it's simple. All you do is you just inject it in, and you don't have to worry about it. You don't have to actually pass it in. The injector will deal with the play framework, and everything will deal with it for you. And then the supply async has an overload where you can actually pass that context in, and it'll override that common pool, and now it's a lot more lax. The only thing to take into account here is this bit.ly takes you to the play framework page about creating a custom execution context. So whenever I said, hey, it's really simple to pass in the execution context that play's using, keep in mind play's using that. So if you're doing any kind of heavy blocking inside of here, then realistically you may want to create a custom execution context. But if it's a pretty simple method, you can just, this simple, add it into the constructor, use it, you're done, and you've fixed the problem. Okay, so the next thing, this is a bit of a duplicate. I did a round a couple years ago about supporting Sparks, but this is a story about no such method in Spark that I think is still, I didn't update the versions and everything, it's a bit old, but it still is very relevant. We get tons of problems around this similar issue. So what is the issue? Actually, before we get to the issue, let's dig into what a no such method is. The key here is it's going to be a class no longer has a definition of that method, and at runtime the definition has incompatibility. The incompatibility has changed. So now we get to the actual issue here being Spark 141 uses math 311, which, as it turns out, doesn't have the natural method. So in this case, it's a customer who was using different versions of Spark, and they end up with a dependency collision. So it was compiled against Spark 1.4, actually, I forget, I believe it was Spark 1.3 or something like that. And then it was run against Spark 1.4, so compilation and everything's happy, but whenever it goes into the runtime, it's using a different version of Spark, and it crashes. So how do we solve this problem? First, we'll cover the Spark-specific ways here, which blend into whenever you run into dependency problems in general. But For Spark, you can upgrade Spark. I mean, it can be simple enough. However, again, if you're working with a larger company, upgrading versions can be a bit of a pain. So that is only going to be available if, that's why I added the if you're lucky, because, I mean, a lot of people don't allow that. So the other thing is we can enforce library load order in Spark. We can say, hey, we're going to add to the class path, and we're going to say this is the version of Commons Math that we're going to be using. It's a bit of a brute force, but it can work. The other option that I think works in general whenever you run into dependency collisions that, for whatever reason, maybe you have to have different versions, is shading. So both SBT and Maven have the ability to shade. And for anybody who's not familiar with it, what shading is it's going to say, hey, I have a different version. And whenever I kind of build it into my package, it's going to kind of obfuscate the name so that the two packages can coincide together. Like what I've written, it's allowed to run because the runtime sees it as a different library altogether. However, like I said, this is going to lead to a separate issue that is more overarching of what we get within support all the time, which is dependency chaos. Sometimes you'll get it as no such method, such as this. Other times, what you're going to end up with is we've had Scala issues where, okay, we have a type mismatch on some generic, yet by all means, it should be working. In this case, it's at least being caught at compilation, but they just can't figure out what's going on. Turns out that it's a incompatibility between different binaries. I think in that case, all they need to do is clean, but these can be really difficult things that you're like scratching your head. I don't understand what's going on here. So again, keeping your dependencies happy is the way to go. Akka itself, Akka cluster, has a way to detect possible incompatible versions in the class path. So it will actually print this message in your logs. I think it's a warning. It's not going to be an error or anything, but a warning that's saying, hey, you've got different versions of Akka across your cluster. So ultimately, there's a ton of problems that you're going to run into that are all based around dependencies. So making sure that you're managing your dependencies as best as you can. Sometimes, like in the case of Spark, it's hidden from you and you have to dig into it. But as best as you can, making sure that your dependencies are all in sync with the libraries you're using and everything is critical to avoiding head-scratching bugs. Okay, so the next item is a value load order. So inside of Scala, we have the problem statement of when starting up a program where, and the key is here, Scala objects are not initialized yet, it fails with a null pointer exception because they're trying to access the object. So this is probably something people are aware of, but in this case, you can mark it as lazy. So they know, hey, a potential solution is change it to a lazy val and it'll end up solving your problem. However, in their case, they need to sometimes use a volatile var because it may change. So just changing it to lazy isn't necessarily going to solve the problem. So again, we know lazy could solve the problem, but in their case, maybe not. So the next thing to do is while objects are lazy, they're instantiated lazily, you can instantiate them at the beginning of your program. So the first reference, I mean, this is, as everybody I'm sure is aware, Scala objects are singletons, so the first time you reference it, it's going to load it, and it's going to cache it, and then you're going to be fine from then on out. So if you do run into a problem where loading order is your issue, then maybe you can just call it at the beginning of your program and just say, hey, I'm referencing it, and just to kick it off. So those are all pretty simple things. However, the reason I brought this up is because, again, Jason Zog on this one too, he pointed out a tool within Scala that I found to be really, really useful. So we're rescued here. And that is, I add the slide to exhibit the problem first, then we'll see where the tooling comes into play. So a pretty simple way to exhibit it is saying, hey, we're going to have this O1 and O2, and the O2 ends up referencing O1's objects. So whenever we come down here and we try to print O1.A, then it will end up printing a null. So we're going to see where this is actually happening by throwing in this throwable print stack trace. And we're going to see that initialization order is kind of the problem, where you see O2, C is calling O1, and basically O1 isn't fully initialized yet, so the whole thing blows up. But, like I said, tooling to the rescue. So again, we know the ways to solve this, but the important reason that I bring it up is if you add this compiler check, X check init, then you're going to get a error here, Scala uninitialized field error, and it's going to tell you exactly where your problem is. So the reason that I point that out is you don't necessarily want to run in production with that check in place. However, in your CI or just your regular development environment, if you just add that simply, then you might save yourself a headache down the road, just because all of a sudden, hey, the Scala compiler is now going to catch these problems for me. It's going to tell me where they are, and I can fix them before it becomes a problem in runtime. So, again, nice little happy thing there to use. The next thing is sorting a map. So, problem statement here is, when we include more than 3 sorting columns in our request, the sorting order of the columns are not persisted. So in this case, the customer sent us code that looks like this. You don't necessarily need to parse the folding or anything like that. This is just to show you what the problem is. And in this case, the problem is here. So this accumulator is a map of a string to a string. And so in their mind, they're adding elements in order. So they're saying, okay, this accumulator, I've added this, and it's in the correct sorted order that I want. And then I've added this and this and this, and it should work, right? But as many of you may or may not know, maps are actually not sortable. So we can actually, like I said, you don't need to care about the code that was there, just the basic problem, because now we can actually see it in a in the REPL, we can just start adding things. It's extremely reproducible. You just say, okay, I'm going to instantiate an empty map of an integer to a string, where it's just the integer to the string representation of itself. And I'm going to say, okay, 1 to 1, 2, all right, we're still in order. We're still in order as we get to 3. We're still in order as we get to 4. And then, oops, one too far. Okay. Then at the bottom, all of a sudden, we had the 5, and now 5 is inserted at the beginning. So again, maps, they're built to be efficient and be able to just hash and look things up. So if you're expecting to treat this like a sequence and actually see it in sorted order or anything like that, you're out of luck. So in this case, like I said, it's actually pretty simple. It's more about knowing the API. It's the same thing with the Akka cluster that we saw earlier. Just knowing the problems is more than half of the solution, is saying, hey, I know this problem, I know the API, I know what's out there, and I can actually make use of it. So in this case, there's actually something in the library, Scala collection immutable list map. And now we'll do the same thing. We had 1, 2, 3, 4, still in order. We add the 5th one, and it's still going to be in order. We can keep going through, and everything's going to be, and it's still going to work. Now, the only thing to know about this class is that it comes with overhead. So, I mean, as you scale out, I mean, you've got the sorting and everything that goes with it, so there's a certain amount of headaches that you might have to deal with if you're trying to run this at scale. So in that case, actually, yeah, we talked about list map. I want to point out that later today, there is a talk on immutable sequential maps, keeping order while hashed, and I believe it's supposed to be a more performant solution, so I suggest maybe checking that out if that's of interest to you. That said, those are the different scenarios that I have here. I actually had expected to run a little bit longer than this, but that's fine. We can have questions. If not, I do have kind of a backup story as no slides, but anecdotal. But I do want to point out that the support team, as well as I think we have some engineering and positions there. But if you like kind of these problems, we are hiring. Feel free to talk to me. Or, oops. You can, if you like to have this level of support and your Jason Zoggs in your back pocket and myself and all of the play engineers and whoever else, then come talk to us. We have a booth and we'll be happy to make you a subscriber so you can get this level of support plus a bunch of other different perks. The other thing is I do want to point out, I like to learn from my talks, so feel free to email me, talk to me directly, or just use the app and just let me know how you think I did. That said, we do have some time, so I can take questions, or like I said, I can even go back and talk about kind of a separate case that's I found to be interesting.
Thank you. Any questions?
Okay. Does anybody, so how many people here have, if no questions per se, how many people here have heard of Alpaca? Great. So we know in general that there's Akka streams, and Alpaca is a way kind of to add connections and get Akka streams and the streaming API and everything like that from different libraries. So the most used library there, I believe it's still to date the most used, is what was known as the Kafka reactive streams, but now it's Alpaca Kafka. So connecting your Kafka streams to Akka streams, or actually it's not using Kafka streams, connecting your Kafka to Alpaca so that you can have a streaming API there into your Akka streams. Recently, we added relatively recently, we added support for transactional. And so the issue that we ran into here was we had a customer who was really pounding it. And they said, okay, well, I have a transactional source. In fact, let me see. I probably can show this. I can show the code, because I don't believe there's anything. Yeah, I double-checked before. There's nothing customer-specific in it, because this was just a proof of concept. So let me drag this over to there. Actually, let me just change my mirroring. Okay. And probably hard to see, though. Let me see if I can bump that up. Rather than playing around with that. Might be a little hard to see, but I'll go over it here. The key item here is these middle lines here where we say, I think this is the one. Transactional. No, this is the consumer. I'm sorry, I grabbed the wrong one. There's the one I want. Okay. Okay, yeah, here is the code. And so you see that we have the transactional source here. So it's a pretty simple API. It says, hey, I want to have transactional. I say, here's my source. You're going to do some kind of propagation. You're going to add some stuff and do mapping and everything like that. And it's really simple. It's just doing really basic, hey, I'm just doing a simple map as it comes in, and then I'm going to output it to this transactional sink, and everything should be happy. However, in the tests, and that gets to the other scenario. So in the tests, they were being run, and it was being run through this this source, which is running at read committed. So all of the things that are suggested for inside of the Kafka API to say, hey, make sure that transactions are happy, is we're going to say, hey, it's read committed. We're going to run it through this this source. We're going to have transactions, and then we're going to sit there and have this size. And so basically, we have it as the size of the list and the size of the set, so that we can say, hey, each one of these, if the size of the set, which is distinct, should be the same as the size of the list, which is not distinct. So as we go through, it's happy, it's happy, it's happy. We get to about, I don't know, sometimes 400,000, 500,000 messages, and all of a sudden, boom, you start seeing the sizes of the set and the list start to deviate. So with a little bit of digging, we realized that what the actual problem was that the consumer was rebalancing. So at some point, some people weren't able to reproduce this on their machines, and that was simply because their machines were fast enough. However, on my machine, I was bombarding it with enough stuff, I guess, I don't know. But I was able to reproduce this, and what you ultimately saw was, hey, as this was running through and printing things, all of a sudden it said, hey, I slowed up, and now all of a sudden I'm going to run a rebalance. And so inside of the Alpaca code, once you dug into it, you found out, hey, I have this this chunk, and it would only, we don't need to see the code for it. So inside of Alpaca, it was running and it was saying commit this transaction every so often. It wasn't necessarily giving you kind of granular control and whatever. So ultimately, what would happen is it would output the messages, and it would end up spitting them out. And Alpaca had its own internal queue of these things, and it would say, okay, now we're going to transact, now we're going to transact, now we're going to transact. However, every time there was a rebalance, it would go through, and you would end up seeing that it wouldn't clear those dirty messages that were in its internal queue. So now it had double messages inside of this internal queue, and whenever it did end up finally get it, rebalance was done and everything, it kicked back to the last point, which was above these other messages, and you ended up with double messages. So it seems like, okay, it could be a simple solution. However, because Alpaca is asynchronous and everything, it became a really tough problem because the source and the sink don't necessarily know each other. So you can't necessarily say, okay, well, this is rebalancing, so go talk to the source, because they're meant to be separated. You don't want them to be necessarily coupled together. However, in this case, whenever you have a flow that is a transactional source followed by a transactional sink, and you want to make sure that they're all together, they need to know about each other. So we actually dug into, we noticed that Kafka streams didn't have this problem, and that's ultimately because some of the stuff that they're doing is using global state, and I believe there's a little bit of blocking at some points. But we wanted to stay true to our nature of asynchronous, message-driven, all of that stuff that's reactive. So ultimately, we ended up pushing out a case. So in this case, it's more anecdotal as an interesting story, because now if you go out and you grab the latest Alpaca, it should just work. But after all that digging, we found out, okay, we had to rebuild internally the source and sink so that they kind of communicate with each other, so that when that rebalance happens, we're going to clear our state. We're going to then, whenever the rebalance has repartitioned things, we're going to say, hey, we're going to start again. Oh, we have the same partition, but all of those things that we thought were already pushed, were about to be pushed, aren't there anymore. We've cleared it out. Everybody's happy. I think there were a bunch of other little bugs we happened to find out in that case, but again, it was definitely an interesting case, and in my opinion, I would love to run some benchmarks against, and this is totally me, this is my opinion, my own, not necessarily light bends or anything, but I would love to run some benchmarks against Kafka streams and Alpaca streams because, like I said, I noticed their way of dealing with it had blocking, I believe some blocking and some global state and things that are just going to slow it down. So fully asynchronous stream transaction, I feel like it actually should speed along even faster than Kafka streams itself. However, you had the pain points that, like I said, I just discussed. So that's all I have, and if anybody has any questions now, go ahead. Otherwise, thank you. And again, feel free to come up to me, let me know how you thought the talk was, rate me. I'd love to improve it or whatever. Thanks.